Okay, welcome to another episode of the Wild Networking series where I read the Cisco design guide. So we wanted to follow the design guide, the example it had on a bad design. One of the not preferred ways to design a network, and of course there's exceptions if you're, I think a clear exception would be like, for example, if you're not using, well, I guess I want to say that if you're not using TCP/IP, it might be a good reason to use this bad design. But I think actually even if you aren't using TCP/IP, you can still use a layer 3 design in your network. Obviously you can't extend it down to your end devices anymore because they don't support IP addresses, but you can extend it down to your access layer still, I think. But anyways, what we were doing is setting up that poor design. So, and this video is going to be kind of interesting because I actually was having trouble with it. So I was thinking a lot about what went wrong. This is the design we're trying to set up, and I think I just had trouble kind of making sense of the extreme switches that I was using, and I accidentally set up a trunk port instead of an access port on those, so like the Vlan tagging is off. So I'll start by doing a capture, packet capture, to see if there's a Vlan tag showing up that's making things tricky. If the Vlan tag shows up on the link to the VPCS, then we know there's probably going to be a problem there. I'm not sure that the VPCS can handle a Vlan tag being sent to it. So that's the first thing I'll sniff once my lab loads up here. Looks like there's some issues connecting to it. So yeah, I'm not sure why I can't connect to my lab right now. It looks like there's some issues. I guess I'll go check on it, I think. I'm not sure. I mean, I didn't, maybe I unplugged it by accident. No, I can still ping it. Alright, there's what I was looking at. So, yeah, okay, it's already started. I thought maybe it had stopped for some reason. So, why can't I connect? And you can't see this because it's on my other screen. So, did I accidentally upgrade my client, or like did one side accidentally upgrade? So we've got 2.2.17 here. Oh, okay, now it's just randomly working. Well, at least it randomly works. That's better than it randomly not working. Although it was randomly not working before. So I can get rid of these hubs. These were just for to show how that why you need why you need to add another layer when you add eventually, instead of just continually expanding out your distribution layer. But here's what we were focusing on. So I'm going to take a capture here, and then I think we'll see tagged traffic on this link, which is not going to work. Okay, so I don't see tagged traffic. Let's try sniffing the other link, because I think it's getting all the way here and then it's going down this link, but I think it's tagged so it can't recognize. And I'm talking about the ICMP. Although I don't think it will be able to send ICMP, because it can only send ARP here. So I think this ARP, nope, there's no tag. Okay. Alright, that's not what I was expecting. Sender MAC address, private. Okay, that looks right. It's not able to respond to that ARP for some reason. But anyways, I do want to try it untagged. I think right now it's set up as tagged on the extremes, so that's the first thing I want to try to get this to work. I have no idea why it's not working. I think it's because I'm tagging the Vlan on the extreme, and I need to untag the Vlan. Oh! It looks like I actually did untag it. Well, maybe I needed to tag it. I'm pretty sure it needs to be untagged, because it's like, it's supposed to be like a an access port. Alright, so let's sniff another link here. We're going to see if we've got tagged or untagged traffic on that link. We do have untagged traffic on these links. So let's see if we've got tagged traffic. Yep, we still got untagged traffic. Alright, let's try pinging. Okay, so we can't send out ICMPs. Oh, we can, until we have an ARP. At least I thought. but this is definitely untagged. I'm confused. Yeah, there's no ARP, so how was it even able to send the ICMP? I thought it needed an ARP in order to do that. Okay, it does have an ARP. Why is it able to ARP for it, but it's not able to ping it? Now this should just be dead because it's blocked by spanning tree, so we should just see BPDUs on here, maybe LLDP as well. No, this should be pretty live even though it's blocked. There we go, so we do see BPDUs on here. Interesting. I thought we would see some sort of message about it being blocked. Huh. Well, that's sourcing from the Hewlett Packard. Yeah, so it looks like there's no BPDUs from the Extreme. Huh. Yeah, I thought a lot about why this wasn't working, and I thought I had it figured out that I had it tagged where it needed to be untagged, but clearly it is just not that simple. So I think what I'm going to do is do a capture on all of these links. So 1, 2, 3, 4, 5, 6, 7 captures we're going to have open, and we're just going to take it from there. So I got to stop them all first. There we go, and then I will start them all. I'm going to take a quick break. Okay, I'm back. We're still diving into this issue. I can only open 6 captures, so I'm not going to be sniffing this top link here. Okay, but let's just take a look at each capture one by one. See what we got. So we do have spanning tree, packets. Yep. So again, here we've got a title that tells us pretty clearly what the capture is. So here's the other one. Yep, everything looks. Don't see anything that looks strange about that so far. We do have a lot of chatter on the network because I enabled spanning tree. I don't think it needed to be enabled on that port, but I did it anyway. Okay, so now we're getting perhaps more interesting. We're getting link traffic between the Extreme and the Aruba, and one thing that is jumping out to me right away is we've got spanning tree traffic sourcing from the Aruba, but we don't have any from the Extreme. So I think the Extreme still needs some work when it comes to its spanning tree configuration, because we want to have spanning tree from both sides. Yeah, sourcing from both sides. We don't have that right now. Okay, so let's work on that. I'm going to open both of the extremes, and then we're going to see if we can fix the spanning tree configuration. So right now the spanning tree configuration is fairly sophisticated. We've got a mode here, mode.1D. We've got a Vlan added to it. So let's see how that mode compares to what we're seeing here. Okay, let's do a Google search for that. Yeah, so we've got a choice between .1D and .1W. So, yep, .1D is just the original, earliest, most basic one. We've also got a choice, we can use 1W as well, that's rapid spanning tree. Now I believe we do have rapid spanning tree on the Arubas, and I think that's the case because if you look at the spanning tree output on them, you'll see alternate states, and I believe those are a part of rapid spanning tree and not common spanning tree. The .D instead of the .W. .D is the common, rapid is .W. So if I do show spanning tree, we've got this alternate port here. I think it's only going to be in role alternate if it's doing .W instead of .D. Okay, so I don't see anything unusual on the Aruba. But you can see it does look quite a bit unusual here. We've got STP disabled on here. That just doesn't look right. So let's try adding the participating VLAN to this S0 instance instead. See if that works. Yeah, so we'll just change, we can probably add it to both of them. Okay, so the other thing we can try is changing this to W, because even though I couldn't find anything that said it was .w with that alternate state. Oh, and here we go. Now I can choose. Let's see here. So I'm gonna see. Now I set it to multiple spanning tree mode. I'm not sure if that's .d or .w. Okay, so this is .1s. Okay, so this, it looks like oh, you know what? I think it's not. So it's not in alternate state because it's .1w RSTP. It's an alternate state because it's .1s MST, and that has the alternate state. It has some of the capability of .1w. But I do notice something unusual here. The default encapsulation is set to .1d. We really want that at .1s ideally. Let's see if that is available. Oh, I'm on the Aruba. I need to do this on the Extreme. Okay, still disabled. We've got a different mode now, but we're still disabled. So the other one is enabled. So let's to go with the original plan, and we'll add the ports to it. We'll add the Vlan to it, and then we'll add the ports to it. I guess before I do that, I do want to see what other options there are for the mode here. Okay. Okay. Alright, so let's try this now. Okay, so it's not a member of the spanning tree domain. Yeah. Okay, so here's the command that we need to use for that other STP domain. Oh, so it looks like I would have to delete. Okay, so now we've still got that E here. We've also got an M, which is it's a MSTP CIST version. But now we've got a topology change detected, and we've got a topology change happening. So that's a really good sign. Let's take a look at our packet captures. So we still only got. Okay, so this is to the PC1, so nothing looks unusual there. Aha! Oh wait, sorry, never mind. This is a LLDP. What I'm looking for in this capture is STP packets from the extreme. And right now I only see them from the HPE Aruba. We don't have a topology change anymore. We do have that E there, which is a lot more encouraging. Alright, so let's see if that solved the issue. I don't think it did, but we will see. I did. Yeah, okay, so the problem was that we didn't have spanning trees set up correctly on the extremes, so the ports weren't processing the traffic the way they needed to. Okay, so the proper way to set up spanning tree, I found, is to just add it to this default instance that was already there. I tried making my own custom instance, and that turned out to be too difficult. I think I might have had perhaps. Well, let's take a look at the configuration for this. Yeah, so it's all default. So if we go, yeah, so this is pretty much exactly what I had for my custom instance. So I really don't know what the difference is between the custom instance and this default one. But clearly the default instance does have some extra things set up on it already that allow it to work where the custom instance was not working. Yeah, but that's real good news. We got our bad design working. So the we should see the ping showing up now on only on the ones. So if I ping and then I hold this up. So let me try that. So we're gonna do a ping. We're gonna do -C 10,000. Okay, and then we'll hold this up, and we should see some of them turn pink, some of them not turn pink. I don't see any turning pink. Am I picking the right IP? Oh, here we go. Here's some pink, but I don't... Or I guess it's more purple. Yeah, I guess this preview doesn't show me the purple. Here's some purple. So we should be seeing the purple on this link, and then of course these two links. So let's look at those two bottom links first and see if we get any purple. No purple. Now, why is there no purple on this link? It looks like there's an ARP, but why are there ARPs? Because I'm successfully pinging. I should see ICMP. Let me filter out for ICMP. Yeah, I'm not seeing any. Oh, okay, I am seeing ICMP. For some reason, like, I don't know, filter bug or something, I wasn't seeing ICMP, but I see them now. So let's see, on the other side here, we'll filter out for ICMP. There we go, same deal, we've got all ICMP. So now we'll look at this link here from Extreme 3 to Aruba 7. So Extreme 3, Aruba 7, we should see some ICMP here. And I clicked a random, yeah, I'm not sure what that, oh, that's to go to the next packet. So yep, now we've got more, we can see our number is incrementing. Now we're getting the returns in here as well, so we see each number is listed multiple times there. Which is kind of surprising for me. I thought we would just see it listed one for each source address. Oh, which I guess is what we're seeing. Oh no, there's one where for the 177th one is actually listed 4 times. Oh no, I see. Okay, we're into such big numbers that it's not gonna go to the next value in the let's see here, the 10,000th place doesn't increment. Okay, so yeah, so now let's look at some more links here. Let's look at this link here between -3 and -8. Filter out for ICMP. Perfect. All right, and we already looked at that final link. So let's take a look at a link that likely won't have these ICMP packets on it. So we'll look at -4 to -7. Filter off for ICMPs. There we go. We don't have any ICMPs because that's not the path according to the. Now that we've got all the ARPs and everything good to go, we're using our MAC address tables that we built out through unknown unicast flooding, and we know we don't need to go down this link. Now, if I were to clear the ARP table on one of these devices, we would see traffic down this link. Even though it would block, we would be blocked. I think this device wouldn't be sending it this way, but we'd still see traffic go down this way. So if and that's if I had an unknown unicast come in. So let's do that. We're gonna clear these two ARP tables here, and we should see on this. Now this is the interesting capture, so we'll leave this one up. We'll close the other ones. Wireshark makes it really hard to close things. I wish I could just turn this off. Like, I basically never need to save a capture. There's basically no reason I ever need to save a capture. And it's highlighted by the default too to save it. Okay, so here's the interesting capture. We should see some traffic if I clear the ARP table. So let's do that. Clear, or sorry, if I clear the MAC address table. So on Extreme, it's called a FDB. Oh, and actually, it's not gonna show up as ICMP traffic. It's gonna show up as ARP traffic. Actually, it should show up as ICMP traffic, right? Because it'll flood it out all ports except for because it's unknown, right? I'm confused now. I'm confusing myself. Okay, I'm going to open up the two Arubas and we'll clear the MAC address on there too. I thought there'd be a way to see the ICMP traffic that I'm sending flood itself down this link. I thought that's a thing, but that might not be a thing. Or at least not the way I thought it would occur. Because I thought you'd get an unknown unicast showing up because the ICMP packet would go into the MAC address table. The MAC address table would not recognize the destination MAC that it's crafted to, and it's crafted to because of the ARP table on PC1, which still has a valid ARP, even though I cleared the ARP tables on these switches. I didn't clear it on the PC, so it's going to arrive, and then it's going to be unknown, and it's going to be a unicast. So the switch is going to send it out of all ports except the port it came in on, and then it's going to learn the source MAC address from which it was sent, so of PC1. So if all of the switches do that, if none of these switches have it, and the packet gets flooded out all ports, the ICMP packet, we should see it get flooded out here, here, and down this link here that we're sniffing. So we should see it on this link, even though it's blocked here. It's blocked on this Aruba. The link is still up, so we should see traffic going in this direction only. We won't see it up in this direction because the link is blocked. Although it might be blocked on that side as well. Maybe that's why I'm not understanding this. Okay, here we go. So we can see, yep, this is exactly as I thought. Oh, actually, never mind. Okay, Yep, so it is blocked on both sides. I had that wrong. I thought it was just going to be blocked on one side, and then on the other side it was still going to be forwarding, but that's actually a much better way. I'm glad it works that way. It's blocked on both sides, so this is just a blocked port. The only thing we see on the blocked port, it looks like are ARPs, which again, I'm surprised we're seeing ARPs on there. And then it looks like we get spanning tree, we get LLDP. Yeah, it's interesting that we get ARPs on a blocked port. That's really interesting. But let's go on the Aruba. We still got our ping going, I think, and we'll shut down 111. And now our ICMP traffic is going over there because spanning tree is going to kick in. Our block port is going to change. Before it was 3, but now that port is going to be unblocked. This port is still blocked. Why is the port still blocked? Oh, you know what? I think I'm looking at the wrong. Yeah, this is -4 and this is -3. So -4, -3. So this link here is no longer blocked. This one is blocked. So yeah. So -4. Link 3, which is right here, right? No, so this is link 4. So link link 3 is right here. This one is blocked. Right? Yeah. So this one is blocked. That's not the one I was looking for. I think it's gonna be link 4. Yeah. So link 4 we can see is forwarding. Let's go ahead and shut this down again, or no, shut it, I mean. And now we'll swing back over. This will be a blocking port, so we won't have any ICMP on it anymore. But we should get our ARPs back. But now if I do a see, okay, so actually I was right. It does work to where it's a port by port basis, not a link by link basis. So you can have a like okay, so this, let me close this. So we're looking at this -4 EXOS device connecting to this -7 Aruba. So we'll see that this 112 port on the Aruba is in blocking, but this port 4 is in forwarding, and that's how it works. I think. Yeah, it's in blocking. So that's why I thought we would see a unidirectional ICMP, and I think we might. I actually never tried that yet, so let me try that. We'll see if we get a unidirectional ICMP. And of course my ICMPs might have stopped, so let me refresh that just to make sure. Okay. There we go. So, yep, so we'll do clear FDB. interesting. So we're getting ARPs, we're not getting any ICMPs. But I think that's actually right. Well, actually no. Oh, you know what's happening? This is actually the ICMP. It's just it's basically like misclassifying it because it's when it's flooded out, it gets flooded out as a broadcast. Yeah, so like the traffic like gets changed a little bit, like when it's unknown unicast traffic that comes in, the switch will actually kind of recraft that. I kind of had it a bit wrong. I thought it was going to preserve a lot of what was in there, and then kind of send out the original traffic and broadcast it. But it looks like that's actually not really what happens. It recrafts. So I am. This is what I expected to see here. I just thought it would be protocol ICMP with a destination broadcast, but it looks like Wireshark sees it as a ARP. So this is exactly what I expected to see. It's just labeled a little bit differently than I was expecting. But let's take a look at the difference between this and that ARP. I'm just curious how they differ. But this is the same thing as the ICMP. It's just the unknown unicast flood because those MAC address tables were cleared out. So yeah, we can see it stripped away the. Yeah, it doesn't. Of course, it doesn't have any layer 3 stuff anymore. So, okay, let's go a bit differently. Okay, that's good to know. That I'm satisfied with that. This is the basically the ICMP, but when a unknown unicast layer 2 frame comes in. So if you craft a frame to a unicast destination from whatever source, and it arrives on a MAC address table that doesn't know that destination, there's no entry for it, it's a little bit misleading to say that it will flood that frame out of all the interfaces. That's actually not what happens. What happens is it recrafts the packet. So it adds the source address to its MAC address table, and then it basically throws away that original packet and sends out a special custom crafted packet that is an ARP, type ARP. And it has a broadcast of all Fs, and then it does have the, and then I believe it has, now here's where it gets interesting. What is this source address? Is it the source address of each individual port, or is it the... Pretty sure this is the, if I do a show IP, yeah, so it's the source of that that IP. Yeah. See, I thought this is actually different than what I thought. I thought it would broadcast. I didn't think it would be. I guess I was confused on that. Let me do this. We're gonna go here and open the Wireshark for this port. Then we're gonna go to the Aruba, and then we're going to clear. Let's see what happens. Oh, I'm not even. It looks like it's ARPing every single time. I didn't think it. I thought if it had an ARP entry, it didn't ARP anymore. But it looks like it continually ARPs, even though there is an ARP entry. That is something I was not expecting to see. Yeah. Let's just do a quick. Just so I recenter myself. Yeah, unknown unicast flooding versus broadcast. So what is the difference between flooding and broadcasting? Broadcasts are sent to a special broadcast address, both for layer 2 and layer 3. Flooding is used by a switch at layer 2 to send unknown unicast frames to all other interface. If a frame is not destined for a host which it receives, the host will ignore it and will not be interrupted. Okay, so thank you. That kind of un-effed my mind. My mind was really getting confused on this. No, the ARP traffic I was seeing on this link was not the traffic I was looking for. I was looking for ICMP traffic with a destination MAC address of that PC2 because when a switch does not have an entry for a destination MAC address, what it will do is it will do something called flooding, which is where it will duplicate it and send it out all ports except for the port it went in on, and it does not use the all Fs for the destination. It uses the destination that is unknown. It does that because by flooding it all ports, it's going to go everywhere on the network. So if there's a node on the network that has that destination address, it'll say, oh, well, this is me. Let me learn that source address, and then let me send a reply back to this. So if you do all Fs with that flood, I guess Oh shoot, am I confused about this? Now, is unknown unicast all Fs, or is it the unicast address? Okay, so unknown unicast traffic happens when a switch receive. I thought it was unicast, not broadcast. Unknown unicast traffic happens when a switch receives unicast traffic intended to be delivered to a destination that is not in its forwarding information base. In this case, the switch marks the frame for flooding and sends it to all forwarding ports within the specific VLAN. See, and this is why I thought I would be getting I would be seeing an ICMP packet, because the frame was encapsulating that packet. So I thought we would see that information persist. We would just see it in weird parts of the network because it was being flooded. That's what I thought I would see, but I did not see that. Forwarding this type of traffic can cause unnecessary traffic that leads to poor network performance or even complete loss of network service. This flooding of packets is known as a traffic storm. No, it's not. I don't agree with that. Okay, I can't tell. Here we go. So this is good. So we've got a table here. So if there's no dynamic, and there probably won't be a static, because this is all the internal hardware has MAC addresses. Then it will do unknown unicast flooding. Oh, that's known unicast, so unknown unicast. When a switch has no entry in its MAC table for the destination MAC address in the frame, the switch sends a copy of the frame out all interfaces other than the interface on which the switch was received. The idea here is that the frame would ultimately reach all hosts, and the host having the same MAC address as the destination address the frame. Yeah, okay. Yeah, I'm right. That is what I thought. I was losing my mind because of what I saw on the network. I was like, wait, it doesn't work like that, does it? And I just completely, I mean, maybe, but the thing is, like, you know, I'm seeing it happen. Like, I'm not seeing what I'm reading here happen in my network. So, like, is this really, like, are they just lying to me? Is everyone just lying to me? because it looks like what's happening here is not that an unknown unicast frame is flooded out all ports except the one it came in on. It's that an unknown unicast frame is converted to an ARP, and then the ARP is sent out all ports except the one it came in on. But I mean, maybe it works different. Maybe only on a Cisco it floods unknown unicasts, and on other vendors it converts it to an ARP. I really can't tell. But anyway, the good news is we did get it pinging with this bad design. Big victory. Wasn't able to do it last night. Was able to figure it out. All I needed to do was fix spanning tree on the extremes. Okay, so the next step is going to be to do a little bit of a better design on it. So go back to the design guide and take a look at what we got so far. So right now we've got this design here, worst possible design you can do, but we've seen it is effective. It's got failover capability. You know, if this is all you can do, it's better than doing nothing, that's for sure. But this is a bit of definitely a better design here, and the reason it's better is first of all, you get more link utilization. Here you've just got 2 dead links that aren't doing anything for you on your network. You can use all of them if you set it up this way. And even this link up here was pretty much dead as well. If you set it up this way, you can use GLBP, so you can use a better first hop redundancy protocol, a Cisco specific one. You can have a easier time configuring them consistently, better convergence time with your GLBP. Yeah, so I guess that's I mean, what more do you need, especially when it comes to I mean, what more reason do you need to use this design other than this design, other than you get 2 extra links in your topology? So 2 full extra links of bandwidth sounds like a good enough deal to me. Alright, so let's reconfigure it to this new design here. First thing we got to do is set up a layer 3 link between the extremes. And I will stop without saving these open captures here. I don't want to exit GNS. Yeah, that's probably what was happening. Is for Cisco's it floods unknown unicast, but for other vendors it converts it to an ARP. I mean, I don't know. I'm still confused about that. Ideally, I would just pin up some Cisco's, and but the Cisco images are kind of hard to get on GNS. You can't just, like, they don't come with the server the way some of these images did. Cisco has more of a kind of they're less their images are harder to are not just a part of the GNS links. Like, you can't just click download and then get an image the same way you could with the Extreme. You can't do that for Cisco. Okay, so let's configure that layer 3 connection. So we can use LLDP neighbors. Um, All right, so we've got, hopefully LLDP will play nicer now. Ah, there we go, perfect. So, yep, the link connecting there is going to be port 3. So let's do configure port 3. And then we're going to need to put an IP address on it. So that's going to be protocol filter IP not compatible. Okay. Interface. I don't know what that ether type means. Maybe it's configure IP. Ah, here we go. IP. This is how you do it. Oh, no, never mind. IPv4. Figure. Definitely want to make a layer 3 interface on port 3. Seems to be a bit tricky though. Don't want a IP route. I mean, we'll take a look at that. So this is for a route. For looks like a static route, you would use that, but we don't want to configure a static route. We want to configure a port. Let's try this. Let's try deleting the current configuration we have on this port, because right now it's already configured. How do I add an IP address to this port? How do I set it up to be a layer 3 port? I wonder if this actually can't support that, because this is probably actually legitimately a switch, not a this doesn't have layer 3 capability, I bet. So if that's the case, then we can't use this for our access layer. We'll have to use that, for our distribution layer. We'll have to use a device that's capable of layer 3. But I'm pretty sure you can put a IP on there. Yeah, so I configure IP. What about IPv6? Is there... Yeah, there's a lot of... IP commands on here, so I don't understand. I don't understand why there's so many commands to do things at layer 3, but you can't do things at layer 3. Yeah, it looks like this is actually a layer 2 switch. So I can only put an IP address on a Vlan. I can't put it on an actual port. Yeah, I can put it on the management interface, but I can't. These ports are only layer 2 ports. They're not capable of layer 3 as well. So clearly this is not a good choice for my distribution layer. Yeah, so this is the FDB is, yeah, the FDB is only layer 2. There's no... Yeah, it's not capable of layer 3. Oh, but you can set up RIP. And you can set up OSPF. It is capable of layer 3. I just don't know how to set it up. Yeah, you wouldn't be able to. I mean, I guess it's not capable of configuring IPs on ports. So you can do RIP, OSPF, all of that, but you have to do it on a VLAN interface. Yeah, so here's how you add an IP address to a VLAN. But you can't add an IP address to a port. I mean, I guess that's fine though, because you can just use a unique VLAN for that L3 connection. So just for this link, we would use, for example, VLAN 10, and that's the only thing allowed across this link. And we've got on interface VLAN 10, we've got connection here. And then for interface for VLAN 30, we're going to have yep, so we're going to have an interface VLAN 30 on here as well, and an interface VLAN 40, and we're going to have default gateways on here so that the PC on VLAN 40 will be able to get routed over to the PC on VLAN 30. So, yep, I think that's going to be the way we'll do it. So we can keep using these extremes. It's not quite as straightforward as if we were to use a different kind of device. I think even on this Aruba here, we can just make the port into a routed port. Yep, so we can do so we can do this command routing, and we can make it into a routed port. So it looks like we can't really do that on the extremes, but as I said, we don't really need to do that. We can just use a special VLAN for it. Okay, so let's start by reconfiguring the Arubas, because those will be pretty simple. Okay, so it's the same deal. We've only got one VLAN coming out, so we actually don't need to change this. Now it would be perhaps nice to have these as trunk ports, because eventually we very likely will need more VLANs, but just keeping it as simple as possible, we won't need to change that, so we won't change it. But here we do need to make changes. These now need to be access ports in VLAN 40. And we can change, let's see here, no VLAN 30. So now we'll make VLAN 40 and we'll name it better design. Int range 1. Okay, so that looks better. We've got VLAN 40. Let's rename it. It looks like there's a... Oh, I wonder if it's just because I created like a new one. No. Let's bring this port up. There we go. Okay, so we'll rename it on the other Aruba. I'm just curious if I've got LLDP. I do. VLAN 30, name better design. 1 through 9. Shutdown, routing. And then it's going to be access 30. Perfect. Okay, so now we've got big changes on the extremes. We no longer need STP at all, but I'll just leave the configuration on there. Oops, it looks like my lab is acting up again. Yeah, I'm not sure what's going on there. It's trying to get a compute list and it's timing out and doing that. I'm going to take a break. I'll be back shortly. Alright, and I'm back. It looks like my lab is actually having a lot of problems. I'm not sure what's going on. Maybe I've got like a broadcast storm or something, but you can see it's just waiting here. I think I'm going to close it for now. Yeah, so we've got this error getting compute list, timeout going for compute, so I don't know what that's all about. So I'm going to close it for now. I'd kind of like to end this video. This was a pretty big victory, I think, for getting this to work, figuring out how to get those extremes configured, and then the next video, even though it was pretty easy on the access layer, I think it's going to be more difficult than I am anticipating on the distribution layer, so I think that belongs in its own video. So yep, that's going to be the end of this video. Next video, I'll be configuring the distribution layer on this design that's better than the traditional looped design, but still a traditional design and not kind of the modern day best practice design. That'll be this layer 3 routed access design. That's the modern day best way to design the network. But before we go and read this section, I'll be configuring this second traditional design in the next video. Thanks for watching and stay tuned.